Hello and welcome to Exam Practice Screencast. Focus today is going to be exercise at heat. Okay, so basically we're going to be looking at some key components. So we'll be looking at the effect of heat or the impact of heat on the cardiovascular respiratory systems, and particularly exam questions can ask you about temperature regulation and also cardiovascular drift. So we need to have an understanding of how these things impact our cardiovascular and respiratory systems. So if we start off then, same principle. You'll get a question, pause it. If you're struggling to answer a question, just with the question, go to slide 2. You'll start to see the kind of triggers that hopefully will help you. Slide 3 will be the answers. So hopefully, by the exam, when the exam comes, you will feel very confident in just pausing it at the first bit and then answering from there. Okay, let's have a look then. So first question: explain how temperature regulation within the cardiovascular system helps to control body temperature during exercise in hot conditions, or in the heat. So basically, you're looking here, and I've tried to kind of highlight the things that I think you should be talking about. So if you want to pause it now, do so. If you need a little bit of prompting, a trigger, then wait for a second. So going on then, let's have a look. The first thing we have to know then, okay, is what is normal body temperature? I think that's a good way to start. Then we need to consider, how does the cardiovascular system control body temperature? What does it do? How does it do it? Okay, so we need to know how it, and you can use this acronym that we used earlier in the year when talking about vascular shunt here. So we're talking about RE, VAS, and this is slightly different in this case. So in this time, we're talking about, you could put a D on the end here, so revast. So you could have a dehydration at the end there. But ultimately, I'll put in red the things that are most important. So the R, talking about receptors. Can we think about which receptor will be most important when exercising at heat? What would it detect? It would detect an increase in something. Then we need to think, right, that information will be sent to this center, the center here, but I haven't put that in. I'm not really that concerned about it for this one. If you wanted to do it just for good practice, you could talk about the center that's responsible for all this, but it's not going to get you exam credit, but it sometimes helps in the process. This then is responsible for doing something to the vessel width. Okay, so this has got a name there. Then we have to say which vessels we're talking about here. So there's two. One begins with A, one's PCS. From there, these vessels supply not the working muscles this time, okay, because this is talking about the concept of heat. When we get hot, what happens? What are we trying to where do we supply it? Instead of going to the muscle cell, we're slightly out from there, and then this leads to the concept of sweating, which is a cooling mechanism. And then if you sweat and cool too much and don't replace it by water, it can lead to a D. So if you remember, vascular shunt is revavast, rebution. Now we're talking about revavast, D. So that the final part is dehydration. So that's me triggering. That's me kind of talking you through the triggers. Obviously, this is something you've got to get away from as you get closer to the exam, but it'll work for now. So let's have a look then. What am I talking about there? Have I made sense? Do you feel like you can answer it from there? Pause it if you're ready to have a go. If not, carry on. So from here then, what is normal body temperature then? Okay, so a normal body temperature is 37 degrees C. So we need to make this is maintained during exercise at heat via a concept called Thermo Regulation. Okay, so how does the CV system control body temperature then? Basically what happens is thermoreceptors detect an increase in body temperature. Now, this then, all that information goes to the VCC, vascular shunt, don't need that, but we do need to say when the temperature rises, there is a kind of a vasodilation, opening of the arterioles and precapillary sphincters, the blood vessels, supplying the skin. Okay, supplying the skin. Now, as a result of that, we then have the process, as you come to here, heat is released via sweat or evaporation, and it acts as a cooling mechanism. Okay, now, the downside to this, of course, it can lead to up to 3 litres of water going in really hot conditions. So therefore, if you do not replenish, that's what people are always saying, drink lots of water when you're in kind of hot conditions. If you don't do it, it's going to lead to dehydration. Now, dehydration can have a negative effect, obviously, because we can't then. It makes it very difficult for us to kind of have this process of thermoregulation. And if we're just thinking about this now, and you've got a question linked to what I've just given you, thermoregulation, usually it would just ask for the impact on kind of what it does. However, if it asks you on performance, of course, if you're getting all the blood, so you think now all the blood is going supplied, so the blood moves towards the skin, all that means is it's going away from the skin, so you're not getting the blood to the working muscles. So therefore, there's a reduced kind of blood volume, reduced stroke volume, reduced venous return, reduced cardiac output. All those things that we need to get the blood back and get it out, all those physiological terms, are lost because all the blood is going to the to the skin, which means that then we struggle to get the blood to the working muscles where we need it. So that is just a thing. If you're struggling on the concept, you can't see how it links to sport, that is why. Okay, so if you can just think of that, if it did ask you to link it to sport and give you a scenario, that's what you would do. However, it's way more important on question 2, which is actually talking about that particular concept of exercise. So explain what is meant by this concept of cardiovascular drift when exercising in the heat. So what we've got to do here then is we've got to make sure we understand the two things that I have highlighted there. So cardiovascular drift and in the heat. So cardiovascular drift, it's got a connotation, hasn't it, of what's happening. It's talking about cardiovascular, okay, so usually that links to a specific thing, and then it's talking about the heat. So we've got to give it context. The context usually means giving it an increase or decrease. Before we do that, let's have a quick look at these concepts here. So we've got to talk about, first of all, what is cardiovascular drift, and then we've got to know caused by an increase in this, okay, so an increase in, see if we can put it around from there. Why does it happen? This is a really important bit here. So why does this whole concept happen when we're exercising at heat? Why does cardiovascular drift happen? And then what is the effect? I've kind of mentioned it before. Okay, we've talked about this maybe going up, but what we've talked about, the effect is that we actually have a lot of decreases in things, and see if we can start to think about how that works. So if we go from here then, what is it? Cardiovascular drift is an upward drift in heart rate, and this upward drift in heart rate, 1 degree in increased body temperature can lead to up to 10 beats per minute increase in heart rate. But what's it caused by? Most basically, if you can just know that described as an upward drift in heart rate, come on, I'm sure we can get that bit. Then it's caused by this concept now. So an increase in body temperature. Why is this increase in body temperature leading to an increase in heart rate? Well, the reason why is because there's an increased amount of muscular and chemical contractions. They have to work harder because we're in at heat. So what it means is because we're at heat, we're not actually getting rid of the heat by a sweat. Okay, so this can cause us massive problems. What happens then? We're trying to get all this blood away. We're trying to get it to the skin. But kind of because of this increased muscular and chemical contractions, we have a problem. At the end of the day, if you're struggling where I'm at the moment, if I just said to you, just need to know this, then you need to know because of this bit is a luxury. It helps understand it, but you can get your marks down here. This is where the big stuff is coming down, the effects. Okay, so what are the effects then on exercise when you're in the heat? So we have a reduced blood volume because all the blood has gone to the skin. Okay, it's gone to the skin by sweating. So this means there's a reduced blood volume, plasma, there's a reduced stroke volume, there's a reduced cardiac output, and there's a reduced venous return. So this means that we're having a real problem getting the blood to the working muscles. So what happens as a result of that? Well, our heart rate is forced to increase to compensate for the lack of blood volume going to where we want it to go, e.g. the working muscles. It's all going to the skin. So therefore, we have that problem. Heart rate increases to compensate. Now, I mean, first of all, and this, I mean, if you want to add a bit before I even put my stuff down, this puts extreme strain on the cardiovascular system, and you see people fainting. You see people, it can lead to death. Okay, if you're exercising in extremely hot conditions. But if we go to the actual performance links, there's a reduced amount of oxygenated blood to the working muscles, which means there's a reduced aerobic performance in activities such as marathon, etc. So this are the kind of things you would need. I've tried to keep talking about these things being reduced, and you start to notice, don't you, there's a bit of a theme. Okay, so you see these reducing in altitude as well. So just keep this idea that when your environmental circumstance changes, okay, e.g. at altitude, e.g. in heat, there can be a real negative effect on the volumes, but this has to increase or elevate in order to compensate. Okay, so just get the idea there. Hopefully you feel like you can have a good go at those two questions. They're the two key things that you could be required to answer. Okay, thank you very much.